we go. All right. Okay, so here what we're dealing with is, I mean, if you remember last time, what we did was we looked at inequalities, and we also started looking at absolute value and inequalities as well with that. So what I'm going to do now is I want to finish this. I also want to post some examples for you guys to complete, to try it out on your own. That's usually what I like to do when I'm teaching in class, in the classroom, not like this. I like to give worksheets, but since this is online, at least I don't think I can do that. But anyway, you'll see what I mean today. So we did encounter absolute value. We did also encounter inequalities. And if you remember, absolute value, the actual definition of it, if you take the absolute value of a number, you could think of it as the distance along the number line between the number and 0. So the absolute value of 4, for instance, would be 4 itself. The absolute value of -4 is also 4, because -4 is 4 units away from 0, just on the left side. I mean, from what I've seen with students is that the distance interpretation is a little bit easier than the formal definition of it, which is also in the notes. So, all right. Anyway, so we also started looking at absolute value inequalities. And basically here, I think if I remember correctly, this is where we left off. Essentially here, I'm telling you how to solve equations with absolute value. Here, W is just any algebraic expression in X. So the absolute value of W equal to B, for instance. So W could be some expression in terms of X, where X is the variable. Basically, you have to solve these two equations. You'll see today when we do an example or two. But this is what it boils down to. So you want to determine when W is equal to B, and also when W is negative B, because that's going to be that. From there, you're going to be able to get the solutions to the equation. And you have these two as well. So, I mean, why these two are true? Why you do this approach? I think I tried to state that last time, but again, if you think about it in terms of distance, it's kind of obvious. So, at least I hope so. But this is in the notes anyway. But I did leave off from here. So let me just keep going. So let's say this is our first example now, okay? So for this example, again, what do we want to do? Well, we want to solve that equation. We want to know for what values of X make this equation true. Well, what we have to do is we have to solve these two equations. That's what we have to do. We have to solve those two. Let me just see something. Just recording, and okay, everyone can hear me. Good. Okay. This is what we have to solve. There's actually two equations to solve. So from here, for the first one, when it's equal to 3, it's really not that bad. It's just solving a linear equation, as I mentioned last time. You just subtract 9 from each side, right? You basically want to get X all alone. And this is what I'm showing you, and this is how you can accomplish that. You subtract 9 from both sides, right? You want to get X all alone on one side. So everything else, you want to move to the other side. So we have 4 times X is -6, okay? Then dividing by 4, as you can see, we get X equals -6 over 4. I reduced it to -3 over 2. You don't have to do that on the exam, mostly because I didn't go over it. Although I guess you should know that coming in, but I didn't cover that though. So if you left it as -6 over 4, that's fine. But that's one solution to this equation, mostly because we have the solution to this equation. Okay, well, now remember, we want to solve this equation as well. So we're going to do that. That's one solution. Okay. So now we solve this equation. Instead of 3, we have -3. Make sure you solve both equations, okay? Here, let me. Make sure you solve both of these. I've given this kind of question on exams, and students would only solve the first equation, so that's only half right. All right, anyway, so we have it when it's equal to -3, as you can see. Subtracting 9 from each side. Again, it's actually the same steps. You subtract 9 and then you divide by 4. Of course, the answer is going to be different because we started out with -3, not 3. And doing so, as you can see, we're going to get -3 actually. Well, that's pretty cool. So we get -3 as the answer here. So in this case, again, there are two solutions. There are two solutions to this equation. We had 6/4, and we have -3. Okay, that's good. Okay. Now, that's one example. Let's do another one. But here, in this case, we're going to do this example. So again, here, we want to know when whatever you're taking the absolute value of, that's our W, or in this case, x minus 2. We want to know when that is less than or equal to 1 and greater than or equal to -1. That's what we're looking for here. Okay, but again, when you solve a compound inequality, right, you want to get x all alone in the middle. You want to get x all alone in the middle. So here it's actually pretty easy. What do? You just add 2 to each side, as you can see. And you get x is bigger than or equal to 1, less than or equal to 3. So we actually get, as our solution set, a closed interval. I mean, I didn't write it here. Oh, I did. Sorry, I forgot. But a solution set is actually this closed interval. So every number in this closed interval is a solution to this equation, and the other way around. So every solution is in this closed interval. That's what we end up with here. Okay, oh, that other one. Okay, this is actually another one that we can do. So we're going to solve this equation as well. Okay. So here, same idea as the last one. I mean, obviously the numbers are different, but it's the same idea. What you want is you want to solve this corresponding compound inequality. You want to know when it's less than 5 and greater than -5. And it's the same thing. You want x to be all alone in the middle. Okay, so what do? Let's subtract 3 from each side, right? Let's get the 3 added first. I mean, I guess you could divide by -2 if you wanted to, but then you're going to have to deal with fractions. Not that that's bad, but I just thought these particular steps would be easier. Subtracting both sides, everything by 3, subtracting 3, excuse me. We get 2 on the right. -2x is in the middle, and -8 is on the left. So now we have this to solve. Now here's pretty easy, right? We just divide by -2, right? So you do that with everything. We have -8 over -2. That's a 4. Here, x is in here because the coefficient's gone. Here we get -1. But notice also you have to turn the inequalities around. You have to turn them around, right? And that's what I did. This one, I turn around to this. This one I turn around to this. Again, that's not because we're dividing, it's because we're dividing by a negative. And that's why we get x less than or equal to 4, greater than or equal to -1, as you can see. And that's equivalent to saying this And so we get this closed interval. I also tell students this. I mean, let's say for some reason you forgot to turn the inequalities around. So if you forgot to, what would happen is you would have 4 less than or equal to x and x less than or equal to -1. But that doesn't make sense, right? 4, you're saying then that there are numbers between 4 and -1. Greater than or equal to 4, less than or equal to -1. Well, there is no such number that does that. So if you forget to turn the inequality around, you'll get something that doesn't make sense, is what I'm saying. All right. Let me just, okay, so let me stop for the recording, okay? Once.